Hello, my name is Rhys Chatham, and here's a brief video on the horizontal coordinate system as it applies to astrological chart calculation. When we create an astrological chart, we're basically freezing the sky in time, capturing a symbolic picture of what it looks like from a particular spot on Earth at the moment someone was born. Let's quickly review first the geographical reference system to get going. The lines going from the north to the south pole are, of course, called longitude lines, also known as meridians. There are 360 meridians, each equaling 1 degree, with each degree containing 60 minutes of arc. This is one of the ways we can pinpoint a location on Earth. We start counting the degrees at a meridian called the prime meridian, which is the starting point at 0 degrees. Longitude or meridian lines go east and west from this line until they hit the anti-meridian at 180 degrees. Now, the horizontal lines on this slide begin at the equator, as you can see with that red line there. And this divides the globe into two equal parts and go up to 90 degrees north and 90 degrees south of the equator. So why only 90 degrees? Well, that's because the north and south poles are perpendicular or 90 degrees with respect to the equator. So with this in mind, let's move now to the horizontal coordinate system. This is the system, the horizontal reference, that sailors and amateur astrologers use to find stars in the sky from their local positions at sea or in a field with their telescope at night. The horizontal system is totally local. It's based on where you're standing. It uses your horizon, your zenith, and the four cardinal directions. Here, let me put the laser on. So here you see the zenith, which is directly above your head. And this line is a meridian, which corresponds to the local longitudinal line on Earth. And here in this green circle, we have the horizon. Now, this system tells you where things are in the sky right now, rather than using longitude and latitude, as we did in the geographical system. In the horizontal reference system, we're referencing the horizon. So we use altitude, or how high something is above the horizon, and azimuth, which is its direction along the horizon, starting with the due north position. And here you can see on the slide the due north position, and that's where we define 0 degrees in this celestial circle. And here you see the various cardinal points. East would be 90 degrees, south 180 degrees, west 207 degrees. Okay, so why is this reference system important? This is because we need to know where our local horizon is in order to calculate the ascendant and the MC in any given chart. So have a look at this next slide. So here we have two pictures from the program Stellarium of the same chart. The blue line on the bottom here represents the local horizon, and this orange line here is the ecliptic. The ecliptic, of course, is the apparent path of the sun around the Earth. So what do we call this point of intersection where the ecliptic meets the horizon? On this slide, you see it here. It's towards the east, and you see it over here. Here's the ocean. And this is the horizon, and this is the point of intersection of the ecliptic and the horizon. What do we call that? Well, if you answered the ascendant, You answered correctly. That's the definition of the ascendant. The ascendant is defined by the local horizon, and by looking there, we can see which constellation of stars are rising. On this slide, you can see that early Virgo is rising at the horizon towards the east. Now, we also need the horizontal system to define the MC. Why is that? It's because the MC is defined by the point where the meridian meets the ecliptic. You can see it on this slide. As the sun goes along its path towards the meridian, which defines the highest point on the path of the sun along the ecliptic, and then it begins its descent. Well, that point of intersection of the ecliptic and the meridian is how we define the MC. And in all astrological programs will use tables that are generated using this horizontal reference system to provide an accurate ascendant degree and an accurate MC degree. So because the sky appears to spin around the celestial pole, and because that pole sits higher or lower, depending on your latitude on Earth, the whole celestial sphere looks kind of tilted from your point of view. You can see that on the diagram here. Now, the steeper the tilt, the more uneven the motion of the zodiac signs through the horizon becomes. And that's why house systems, quadrant house systems like Placidus and Koch can get a little bit strange at higher latitudes. And we'll talk about that more in another video. But for now, this tilt plays a big role in how the sky appears to move where you are, how the stars and planets rise and reach their peak and set. And in quadrant houses, that's what makes this tilt is what makes some houses larger and smaller than others. In addition to the horizontal coordinate system, for precise calculation of the ascendant, we have to also draw on two other coordinate references, the equatorial system and the ecliptical system, which provide different sky perspectives that are essential to finding the ascendant and other astrological positions. I'll be posting videos describing these reference systems in the coming days, but before I go, I wanted to mention a course I'm giving at Kepler College on astrological house division. In this course, we'll study how the major house division systems are calculated in a way that doesn't require any math. We're not going to be advocating the use of one house system over another. We're simply going to describe the different house systems and why they were calculated, what the astrologers who invented them had in mind when they made up these systems, and we'll reflect a little bit on the symbolic implications of each of them and how they might impact on chart interpretations. So hope to see you there, and I'll be back with more videos soon. Bye for now.